Hi, welcome to the section Project-Oriented Workflow. The idea of this section is to show you the best practices on data management and data analysis for the upcoming sections. Here in this section, we are going to talk about the difference between script versus project. And what is an RStudio project? What is a directory structure that we try to advocate for the best practices in data management? And how is our workflow that we perform for the analysis of the tricot data? So what is a script? Script is an R script, or basically a script is simply a text file containing a set of commands and comments. The script can be saved for the later use to reuse the saved command. So the script is basically like, for example, a recipe for a cake. So imagine that you want to bake a cake. So you just write the recipe, and then you have the commands for to follow the idea of baking a cake. So this is an R script in terms of computer language. And the data analysis in a script-based approach means that every time that you need to run the script, that you have to execute the analysis, you have to set up the entire workplace. So coming back to the idea of the baking cake, so this means that you have the recipe, and also you have to set up all the kitchen to bake the cake. So it's not only baking the cake and using the recipe, but it's like you have to set up the kitchen for it. And sometimes like the inputs can change, like if you can go to a different kitchen. So then it's sometimes you don't find the what you need, it's like the elements that you need for the baking cake. So this is basically what is a script based, like a script based approach. So means that you have to set up everything, and it's more difficult to replicate the analysis or the process that you require. So in terms of project, it means that is a folder on your computer that holds all the files relevant for the particular piece of work. So this means that you have everything. Coming back for the analogy of the baking cake, so it means that you have everything to baking the cake, not only the script, but all the elements for the script, for the cake, like the wheat, flour, the sugar, the cream, everything, you have it already in the kitchen. So this means that you have everything set up for your recipe. So this means that any resident script is written assuming that it will be run from fresh R product process with working directory set to the project directory. So you don't need to change location of objects. So you don't need to look for the sugar in your dorm room, or you don't need to look for the wheat in the bathroom, for example. So you know that everything is inside the kitchen. So this is the analogy. And this convention, like making sure that all the data and all the script and all the elements are inside one folder that is a common folder, guarantees that your project can be moved around on your computer, like if you want to move to other folder, or onto another computer, like if you want to share it with your colleagues, or if you are working with teams. So it's better to work in this approach, because everything is inside this folder, and don't need to go to other to look for elements outside it. If you need to read more about this, just click here in this button. There is a very nice blog about this, like in this book for the RStudio group. So showing how is the workflow process. And here I have one example from a study of Moyo and et al. About sweet potato. So I'm going to show, this is the paper now showing the analysis on sweet potato, testing the data of crowdsourcing citizen science, the tricot-approach in Ghana, in Uganda. So this project, this paper was analyzed, and everything was done based on this approach, now the project-based approach. And I'm going to show you the structure of it. So this basically what is the structure of the folder. So then we have the main folder, like the main directory, and then inside it we have one file which is called .approach. Now they depends on the name of the file, so the folder. So this folder, for example, is called sweet potato zip tricot. Now, so this is the name of the folder, and then this is the project. So this what this file means. This is like the main file, like the core file for the project. Is the file that is generated by RStudio, an RStudio project, that is going to be opened every time that you need to run the analysis. So you don't need to stay like clicking on scripts or clicking on input data. You just need to open this file, and then everything will be set up for you. So it's like going back to the analogy of the baking cake. So this means like this is the door of your kitchen. Now you don't go into the kitchen from the windows or from the ceiling. You go from the door. So this is like the door, the formal door to get into the kitchen and baking the cake. So then we have the folder which is called data. So this folder contains all the inputs files that are ready to be analyzed. So all the files that are going to be analyzed in your project are inside this folder. So for example, in the case of this analysis from Moyo and collaborators, we have two files. One is called sentiment/potato_potato and .xlsx, and then we also have another one which is called spotato_data.csv. So these two files are the ones that we used for the analysis of this paper. But inside of it, we also have a subfolder. So I also say this here now, so that we have a subdirectory called raw, which contains some sensitive data or raw data. Now, so for example, imagine that you have data that you don't want to share with others. Now, so then you use this folder called raw, and then inside it you hide the data which is more sensitive. For example, the name of the participants or the cell phones, things that you don't want to share with others to avoid problems with the privacy of people. So for example, if you see this folder, I took this screenshot from my local computer, but this folder is published on GitHub. And if I go here to check it, and I go in data, for example, we don't have the file raw because it's hidden. I only myself has it because I don't want other people to get access to this one. So this is where you can put the files, the files that you don't want people to get access. And the other one, it's called script. So in this folder we have all the scripts that is going to be used for this analysis. And the best practice that I recommend you is that you name the scripts with numbers in the beginning. Well, for example, this one is 01, 02, and 03. So we have 01 clean and combined data. So this is with these naming practices, we know from which script we have to start with. So I know that when I open this data, even if I never touch on it, so I know that I guess that the first script to get is this one, clean combined data, because it also has the number of 01 and then 02 and then 03. So here I have all the scripts, and also another comments that I also have one thing that's called old script. So when you are doing the analysis, sometimes you try things and you test and you see that sometimes it doesn't really work for this kind of analysis, but you expend some time on this, no? So I recommend you that you don't erase the script, no, you don't delete it at all, like from the beginning, but you keep it from you never know if you're going to need it in the future, no? So one idea is to put it in a subfolder called old scripts. So then you put all the scripts there, and you just check, for example, in the future, if you can remind that you did this process for something else, and then you can go back to it. And also have one thing that's called session info, which is information about which kind of R packages and which versions of the R packages I used, and what machine that I used, and all the things that help me to understand if I find any problem in executing the data in the future. I can come back to the version of the package or the software that I used without any trouble. And then the other thing is this one that is called the output. So everything is written inside this folder. Now every output that comes out from the analysis is written in this folder. And an optional folder is this one called manuscript. So in the case that you want to write your manuscript in LaTeX or R Markdown or any other kind of even in Word, you can just put all the files here, and you can write the manuscript or the reports in this folder. Now then you can share with people the entire project. And also it has a file which is called the README file, which is the file that has important information for people that need to learn, need to know some things before doing some analysis or looking at the folder that you are going to share. So this is one example of the structure of a project-oriented workflow. Now, when everything is inside the folder. If you look at here, I don't have any data that needs to be taken from other places rather than this main folder. And what is an RStudio project? Well, I was talking about this previously. So an RStudio project it's the simplest way to create a project-oriented workflow for you. So it sets up automatically the work directory for you, so you don't need to stay setting up the folder that you're going to work with. You just need to open this file that I said before. For example, in this case, is sweet potato zip tricot, but it will change depending on the name of the folder that you have. And it easily separates the workspace and command history. And also it's easy to share and ensure reproducibility. So you just need to pick this folder, and you share with other people, and it will be like, I cannot say 100% because some mistakes can happen when you set up the folder, but it's very likely that your colleague or the person that is going to get this it can reproduce the analysis that you did. If you need to read more about the RStudio project, just click in this button. And here we have the guideline on how we can create an RStudio project. And also, if you look at on Google and on another searching engine, there is a lot of information about it, and you just need to look at it. And there is also tutorials on how to do it. In our workflow, with the one that we employ here in the analysis of the tricot data is basically this one. We have the data that is produced by several participants. As I said, this is a crowdsourcing citizen science approach, so we have a lot of people contributing to a single aim. Now everyone wants to reach the same aim, but everyone contributes with a small piece of tasks in this common aim. So all the data after that is collated, it's put it all together, because we have a ranking based approach, which makes quite easy to combine the data. And then what we do is if we have any, we combine the ranking data that comes out from the participants on the approach. We combine it with explanatory variables. For example, if we are working with on-farm trials, for example, we can pick the planting dates and the geographic locations, and with these two information we can derive environmental indices from precipitation and temperature. So then we can create a lot of environmental indices to explain the performance of the crop in on farm. Sometimes if we have DNA data, we can also add the DNA data from the varieties or the genotypes that are being tested on farm, and we add it, and then we go to a process that is called model selection. So then we select the model that better explains the performance of the data that we have produced. In some cases, this is native to CleanUp. The participants that contributed to the project get a report informing them which an overall perspective of the data that the entire trial. They get to know which variety was the best performing across the entire trial and which one is the worst performing, and how they evaluated the 3 varieties that they got, and how it fits compared to the other colleagues that evaluated these varieties as well. But in the case of our analysis, we go a bit further, and then once we select the model that is the best one for explaining the data, we then create a stable partitioning tree, which is a decision tree for the data that is produced. And using this tree, we can go a bit further in the analysis and looking for insights in this tree and try to make predictions and see how this can derives into recommendations to crop variety management, for example. These are the R packages that we developed to support this workflow. We have for the date we have 5 R packages that can be used in this workflow and support it. One of the main R packages is this one called CleanUp Tools, which is an API client for the CleanUp platform. So this means this package has a few functions, but the core functions of this package is to get the data from the CleanUp platform and fetch it into the R section. So then you don't need to download as a CSV file and then read it on R or any other language that you or programming that you use. So you just need to fetch from CleanUp to R, and this is quite good because you don't touch the data. So you are just taking like a mirror of the data, and you are not touching the original data. So it doesn't matter what you do with the analysis in R, the data that you have in CleanUp will be intact. So will be 100% not touched, and then you can just go back and take the original data if you want. The Gosset package offers a toolkit for this workflow, from transforming the tricot data into a placket loose data, for example, and also performing some visualization tools to check the data. The placket loose package is the one that provides all the functions and all the fits of the models for the placket loose model that we use in this analysis. And the packages chirps and climaterns are the ones that we use to produce the environmental indices to combine the rankings with the environmental performance or the environmental characteristics of the on-farm trials. And thank you a lot for watching this section. I hope that you learned and that you use the project-based workflow in your analysis. So this will make your life easier. Be sure of this, and also the life of your team, your colleagues, also easier. Stay tuned for the next section when we are going to talk about the R program.